Welcome to VMware vDefend Security for VCF 5.x. I'm Chris McCain. I am a director at VMware by Broadcom, specifically working in the Application Networking and Security Division. This is Module 1, Private Cloud Data Center Security. In this first module, we're going to take a look at data center security, both from a historical perspective and then a new approach. The goal is to lay the foundation for what the rest of these modules will cover as part of the security solutions that we offer at VMware by Broadcom. This first module will take a look at attack chains, how we can mitigate attack chains, and really what differentiates the vDefend security product and makes it the best for your private cloud. Let's start by looking at some realities of security within the enterprise today. There's a lot of operational inefficiency and unmitigated risk. First, starting with lack of visibility, especially in hybrid environments. A lot of times, both the infrastructure admins and even the application developers who build their own apps don't have a strong grasp on the way that the application needs to communicate among the components that make it up. So this lack of visibility for the business and the app owner creates opportunity for them to miss important or critical things that happen in the enterprise. Now, looking at most heterogeneous environments where there's different tools and different platforms, we then find that there's a lack of automation, or if not a lack of automation, certainly a complexity to automation that makes it very difficult to scale. The lack of communication between the infrastructure and the app teams often causes tremendous issues and creates unmitigated risk in the environment. And finally, a lack of application awareness because of network-based security policies. You know, back in the day, applications were built on networks that were fairly static, and that was okay. It served the purpose. But as the applications have evolved, so too have the networks, so too have the security tools. And now we're dealing with environments that are much more dynamic in nature. There's a lot of news every day, something new about some type of attack somewhere in the world, some vulnerability, some company being breached and data being lost. If we take a look at just some of the most common statistics that we can find, 44% of breaches perform some form of lateral movement, meaning once an attacker gets in, they want to move from one resource to the next until they find something of value. Now, in this lateral movement, it's noted that 2 to 3 hops is the most common, very rarely 4, making this swift closing and laser-focused propagation attempts. The attackers know exactly what they're looking for, and they know how to find it quickly. How do they do that? Well, 64% of the time, it's using the Samba service, pass the hash, or even the remote desktop protocol. So very common things that we allow in the environment. In the past 12 months, 55% of organizations have reported a lateral movement attack. We have usage of zero-day exploits up by 11% from 2021 to 2022. Exploits of vulnerabilities and containers also up by 11%, 64 to 75%. And while these numbers might be a few years old, we can only expect that these are probably going up as opposed to going down, as we are not mitigating at the same speed that attackers are evolving their techniques. 57% of organizations have reported some type of ransomware attack. 67% have reported API attacks that accounted for up to 20% of all threats, with data exposure as the greatest vulnerability. And 65% report that cyber attacks have increased since Russia invaded Ukraine. So just some statistics to be found on the internet. Well, let's take a look at VMware vDefend. VMware vDefend is a new way of thinking about private cloud security. VMware vDefend is security for east-west, as well as creating zones or your cloud edge traffic. It begins with the opportunity to protect virtual machines, containers, physical servers, or even out into the VMware cloud. It's elastic in nature. It has very rich contextual awareness of applications. It does not require any network changes, which simplifies the deployment, reduces the complexity of getting it into production, and then integrates tightly with automation tools. The vDefend security portfolio is made up of the distributed firewall, the gateway firewall, the advanced threat prevention, and then also includes security analytics and management. So everything from firewall capability for app and user ID, FQDNs and malicious IPs, into IDS, IPS, malware analysis and malware prevention, network traffic analysis, and then the analytics and management giving you app flow discovery, rule recommendations, policy management, and network detection and response. Let's take a look at visibility and enforcement across the attack chain from the perspective of legacy type security solutions versus vDefend security solutions. In the legacy model, when you want to introduce firewalling, this is done using physical devices or devices that require you to move across layer 3 networks. This can often be very manual and labor intensive and requires you to build your policies based on IP addresses and subnets. If you want to introduce IDS IPS, again, another appliance being introduced into the network, an appliance which doesn't have any environmental context, as well as east-west visibility, and can often result in a high false positive rate. If we want to get some more advanced security services and introduce a packet broker to get network sandbox, we now add more physical appliances to the network. The downside here is the detection technology is easily bypassed by evasive malware, and oftentimes they fail to detect advanced threats. And then finally, your network traffic analysis. The physical devices that traditionally do network traffic analysis are difficult and costly as they hairpin 100% of the traffic to a particular device and often have high false positive rates. So these security tools are very important and they're very powerful, but the traditional model makes it very difficult to get them into the enterprise environment. If we contrast that with vDefend, vDefend leverages the distributed architecture of the hypervisor to take all of those security services and bring them closer to the workload inside VMware ESXi. These are hypervisor-based advanced threat protection. There's no network changes required. We have hypervisor observability, the ability to create firewall policy to do segmentation all the way into microsegmentation, and then adding network detection and response, tapless network traffic analysis for east-west visibility, a sandbox, and distributed IDS IPS, as well as network event correlation. Looking at a complex attack chain, here we have a simple network diagram of an infrastructure. And if we put all of the appropriate security tools in place, both at the hypervisor as well as in our gateway firewall, we can see the different levels of security protection that you get with VMware vDefend. So the distributed components inside the hypervisor and the gateway components inside of a virtual machine or physical edge appliance. And we'll get more into both of these products and features as we move through the course. Attackers, as we look at the attack stages, stage one, delivery. How do we get into an environment? Maybe it's a VDI system. Employee clicks on some unknown link, opens something that they are not supposed to, and we get delivery of some malicious payload into the user's desktop, virtual desktop. Then we have command and control traffic, followed by port scanning. Remember the 2 to 3 hops, moving strategically in a laser-focused way to find what it is they're looking for. Then we move laterally once we find what we're looking for. So maybe it's the use of remote desktop protocol to get from one system to another, an RDP hijacking session to be able to get into that Windows virtual machine. Then the dark side download, the exfiltration of data. And then finally, the files get encrypted and we have a ransomware event. So as these attack stages go through, you can see the coloring in the attack stages mapped to the security mechanisms that we can put in place to detect and prevent these very stages. So distributed IDS IPS with gateway firewall IDS IPS to identify exfiltration attacks, the distributed malware detection and the gateway firewall malware detection to inspect against delivery, and then of course the network traffic analysis and or network detection and response to identify the lateral movement. So where do customers typically start this journey into securing their infrastructure? Now, there's no one way that is correct for every customer, but if we have to lay out just a plan that customers can follow, step one might be just visibility, understanding what's in the environment. How do I know how my applications are communicating? So getting application visualization, leveraging tools that don't have any east-west blind spots, leveraging tools that don't require network taps and hairpins. And then also very important as a key value prop is how do I get policy recommendations? But I don't want recommendations against a legacy security model. I want recommendations against a new mindset towards security that makes it easy to scale and manage for the entire enterprise. So in this case, we can use something like security intelligence. Security intelligence will give us all the information about the east-west traffic within our enterprise. Now, who would be the person to do this? Could be the network team, could be the network security team, or as I'm seeing now, oftentimes the virtualization team trying to get a rich understanding of how their workloads are communicating. Step two might be segmentation, reducing the attack surface by segmenting or micro-segmenting workloads, stopping obvious anomalous traffic, limiting the blast radius, creating segments with no network changes, and establishing zero trust for workload access. The key technology here would be the vDefend firewall as well as the gateway firewall. Who would do this? Same personas, might be the network team, might be network security, might be virtualization. The next step might be in-band threat inspection. So looking at strengthening the protection of enterprise communication. Key value propositions being protecting from known bad threats, detecting zero-day malware, and implementing behavior-based anomaly detection. And we can do these things with the advanced threat prevention from vDefend, using IDS IPS, NTA, NDR, and sandboxing. And the personas here might be the network security team or now the security SOC team, although I wouldn't rule out the opportunity for a virtualization team that is trying to take on more of a security-focused role in an effort to build a sustainable private cloud that they can use a single set of tools to understand everything going on in that private cloud. And then the final step is getting out to the multi-cloud, extending the single operational model of VMware Cloud Foundation into other VMware clouds. So having consistent security policy between your on-prem and your VMware Cloud in a hyperscaler, leveraging security automation to simplify the way rules are built and processed. And then the technology's positioned here, obviously vDefend distributed firewall, which is capable of running in your on-prem as a security add-on, as well as any of your hyperscaler clouds like VMware Cloud on AWS or Google Cloud VMware Engine, Azure VMware Services, all capable of supporting the vDefend security portfolio. And as far as the personas go, this might be the security or SOC team. Maybe there's a dedicated public cloud team or cloud team, the network team, or the virtualization team. So what you should take away from this particular slide is a few things. Number one, there is no one correct way to deploy. As an organization, you might feel like you want to start in step two and just get some quick, easy wins against the malicious use of common protocols. Or as an organization, you might feel like there could be a compromise going on now. And so you start at step three to get an idea if there is anything malicious going on. As an organization, you may not have any business plans to get into a VMware cloud on a hyperscaler. And so step four would not be something that you reach. So you can mix and match between these different steps as you see fit for your organization. The other thing to notice is the personas. It's not any one particular persona that has to handle these security technologies. We are certainly starting to see virtualization teams extend their skill sets into security so that they can play a more powerful role in the overall security posture of the organization. The three components to cybersecurity design. First, you have to be proactive. And by this, what we're talking about is what are the things that I can do to stop the things that I know could be compromised? If you know that the most common attack methods or the most common lateral movement methods are RDP, SSH, SMB, then why not mitigate the malicious use of those by building policy? Quick, easy things to do. We can do this with firewall, IDS, IPS, NDR. Now, once you have some proactive protection in place, you also want to make sure that you have a really deep visibility into the workload. You want to understand if there's anomalous traffic going on. You want to understand if virtual machines that have never talked to each other are now talking to each other. And if that's the case, why? Is it legitimate communication? Has something changed with the application? Or is there lateral movement going on where an attacker is communicating to a workload in a way that compromises the enterprise? And then finally is recovery. In the event of an unavoidable cyber attack, do you have the plans in place to quickly return the business to working order? Do you have immutable backups? Do you have something like a ransomware recovery playbook? Do you know what the blast radius would be based on your proactive security design? So it's really tough to try and put yourself in a position where you are 100% protected because threats evolve. Zero-day attacks happen. And then ultimately, humans are involved in all of this. So there's no way to truly be 100% protected. But if you look at these three areas here, it would seem that the more time you spend in the proactive section, that you're reducing the chances that you would have to spend in the recovery section. So it's not to say one is more important than the other because, recovery, you hope that you never have to use. You could spend a lot of time building a very strong recovery plan, but ultimately you will hope that it never happens, that you never have to test that recovery plan because something has actually happened. So when it comes to visibility, there are often challenges with network visibility. Applications on the network and their communication patterns, maybe applications have been running for 5, 10, 15 years. The individuals who deployed them or developed them may no longer be with the organization. So understanding their patterns can certainly be a challenge. Are the current firewall rules correct or effective? So if you're implementing legacy technologies for these applications, do you have the right policies? Are they effective for preventing malicious use of ports and protocols against those applications? What microsegmentation policies do I need? Are these communication patterns normal or abnormal? So data center networks host thousands of application components. It's literally a black box for most network security teams. When we look at the threat landscape, a data center that might be under attack, and we saw a quick introduction to this before, we'll look at it from a little bit different perspective here, but attackers, the threat actors, moving through a perimeter firewall easily into a virtual desktop. And this can come from partners, contractors, support staff, consultants, internal employees. Anybody who has access to the environment is certainly a target for a threat actor being able to gain some sort of entry into the network environment. Then they distribute these malicious code or executables in order to hinder the environment. So there could be a malicious archive download. From the malicious archive download, we're then looking at discovery, credential access, lateral movement. And this is not just isolated to technology things. There could be social engineering involved in here, the ability to steal somebody's credentials by trying to socially engineer a help desk. So we can't rule out the non-technical threat actor techniques that also get put into play. From there, we might have a DNSCAT data exfiltration, back to the threat actor, some deleting of shadow volumes and backups. Attackers that are sophisticated enough to understand the way you might try and recovery can oftentimes find ways to delete the very things that you are trying to use to recover in the event that these things happen. And that's why your recovery plan is extremely important to make sure that it cannot be compromised. And then last and not least, the double extortion by exfiltrating that data and then ransoming that data. So very straightforward, yet oftentimes a mix of very simple techniques with very sophisticated techniques. In today's typical networks, we look at security postures. So here we've got 3 different VLANs, one VLAN for our virtual desktops. We got 2,000 endpoints communicating externally and oftentimes with no security. And those endpoints have access to other VLANs that host web servers, databases, applications, whatever it might be. And it's just simple routed traffic within the enterprise. We can add data center perimeter firewalls, and we can add internal firewalls in order to control traffic into specific VLANs. But as mentioned before, this can be complex. We have to insert this physical device into the network somewhere and be able to force traffic through this firewall in order to get any type of inspection. So this legacy segmentation approach means adding more and more firewalls, more and more complexity. So for smaller flat networks, you can get better enforcement and visibility, but the bad part is complete network redesign, which can be very expensive, adding all of these new firewalls into the mix. Also not having the visibility and control in a way that makes everything complete. And then, of course, as the traditional model requires, you're doing all of this based on IP or subnet. And then, of course, the ugly, re-IPing applications might be necessary, which is often problematic. And then the firewall configuration is also tightly coupled to the network design. So as you add more IP subnets, you need to revisit the firewall policy in order to ensure that the new IP subnets are able to communicate the way you expected them to. The legacy firewall operations, right, based on IP subnet is very labor intensive. There's no automated scaling. It's near impossible to audit old rules at scale. And the snowflake firewall configs, those one of one configs that are tied to the network architecture, are often difficult to manage over time. So with vDefend being embedded into the hypervisor, instead of it being an agent inside of an operating system, instead of it being a physical device, being built into the hypervisor is an extremely unique architecture. If you think about the competitive version of trying to achieve security that requires the installation of an agent or something inside the operating system, you'll see that oftentimes this is the weakest security being commingled with the operating system. Mainly because in the event that the application or the OS stops functioning properly, one of the first steps in troubleshooting is to disable agents, at which point you lose your security. So there's no support for VM appliances with the Agent OS model. There's no IDS IPS built into it. There's no protocol aware rules, and there's oftentimes performance issues. So the agent or OS, although it might achieve a certain security posture, the architecture does not lend itself to being extremely scalable and does not lend itself to being easily managed. And at the same time, it can create problems with the operating system in which it's installed. If you look at the physical firewall, we mentioned that they are physical devices that have to be configured manually. They are often labor intensive. There's no east-west visibility or control. And then, of course, the rules are based on IP or subnet. Okay, so if it's not in the OS and if it's not in the physical network, the space in between is the hypervisor. And so that's what we've alluded to here a few times now, is that vDefend is a very unique architecture. It's an architecture that allows us to take advantage of the distributed compute that VMware has built its business on for over 2 decades. This hypervisor-based firewalling is an agentless security. So nothing has to change inside the VM. Nothing has to change at the physical network or overlay. There is automation capability to create dynamic policies. There's really strong east-west observability and security. It is virtual machine attribute based if that's how you want to design. It includes a distributed IPS feature and has layer 7 app ID rules. So we're not talking about just the abstraction of a firewall. There's really nothing special about the abstraction of firewall. But what you will find throughout this course is that the power of vDefend is in the operational model for that abstracted firewall. Yes, it is a unique architecture. Yes, it is VMware's competitive advantage to own the hypervisor and be able to put all of these security features into the hypervisor, but that wouldn't do much good if it was difficult to manage. And so the ability to simplify, to reduce the complexity of managing firewall policy or advanced threat prevention at large scale across the enterprise is definitely one of the largest benefits. So there's an NSX Manager graphical interface that you can use. There's an API that you can also use to create your centralized security policies. This ties directly into the vCenter server, which means that it has rich contextual awareness of things like the virtual machine inventory, the virtual machine attributes for establishing policy elements. And that tight integration is really what makes it easy to manage. Let's take a look at the idea of defense in depth and see why we focus or suggest that you use a best of breed type VM security in the enterprise. So we've got a SQL Server database. There's a handful of ports that it uses. There's already a perimeter firewall or some type of zone firewall, and there's application traffic into this SQL Server. So the perimeter firewall, of course, your first line of defense, giving you some controls. But within the environment, when we talk about east-west, we're opening specific ports and protocols. So with vDefend, we're talking about east-west controls in a way that provides agentless firewall, that gives you the ability to create microsegmentation policies to reduce the attack surface. Some ports are required, some ports are not required. Why leave unnecessary ports open for a threat actor to be able to utilize those ports? We have agentless IDS IPS. So for ports where we want to allow communication for those remaining services that we require to get into the SQL Server, we have the ability to inspect that traffic and to map that traffic against known bad attack methods. And we can wrap all of that inside of tapless visibility with NTA and NDR so that we get network visibility at a very low granularity for every single workload that we have. Now, this defense in depth to protect the data center, if we walk through the attack chain again, and we're wrapping all of our workloads with this agentless firewall, and we have attackers that are trying to use known attack methods, yet we are wrapped with our IDS IPS and our network visibility. We can find that there is very strong mitigation against what attackers want to do. So in the event that they get into a particular system, we have the ability to detect and respond using distributed firewall, distributed IDS IPS, as well as NTA and NDR. If there's an attempt for lateral movement, we've got visibility and alerting to be able to mitigate attacker dwell time in the environment. We can receive IDS alerts, NTA alerts to let us know when these types of events are occurring. And all of this ties into our intelligence and NSX NDR to be able to correlate the traffic to know when there is an attack campaign in the environment. Security intelligence is our visibility tool to give app flow visibility, giving contextual visibility with color-coded flows for DFW rules. It eliminates blind spots with comprehensive visibility into flows and the posture with full visibility to east-west traffic. Not sampling, not spanning, not tapping, but full visibility to east-west traffic. And then enhanced context. So providing visibility to process and application visibility with layer 7 context. So the collection of this information and add in the AI and ML driven anomaly detection, we now have the ability to understand what baseline traffic looks like and then what anomalous traffic looks like so that we can be notified in the event that things start happening that haven't historically happened in the past. So the analytics and automation drive that AI and ML anomaly detection. In summary, vDefend is your strongest threat defense. And the architecture, by taking NTA, NDR, sandboxing, IDS, IPS, firewall, and putting them into every hypervisor, means that your data center can scale easily. Every new node that you add, every new cluster, every new rack is not just adding more CPU and more memory and more network adapters. It is also adding more firewall, more IDS IPS, more NTA, more NDR, more sandboxing, which makes it very easy to plan and manage in large enterprises. So visibility and granular control for internal lateral movement, lateral traffic, lateral threat detection and prevention inside the network, and application agility with security. In summary, let's do a quick comparison. Traditional security versus vDefend. Traditional security is often perimeter oriented, whereas vDefend security is segmentation or micro-segmentation oriented. Traditional security is often device-based architecture versus vDefend being distributed architecture. Thousands of IP-based rules in the traditional security, where vDefend is using intent-based dynamic policies. Only ingress-egress threat visibility for traditional security versus lateral attack visibility for vDefend. And then finally, the traditional security is limited security at a high cost, where vDefend is a comprehensive security with a lower total cost of ownership. So with vDefend, we can achieve part of our zero trust network security projects. We can deliver security that scales with your cloud. We can deliver advanced threat detection and prevention capabilities in a manner that's simple to deploy and simple to use. That concludes Module 1. Thank you.